Have you seen a dartboard, ripples in water, or the rings inside trunk? What do they all have in common? They are made of concentric circles. In today's lesson, we learn what concentric circles are, their properties, formulas, solved examples, and some exciting real-life applications. What are concentric circles? Concentric circles are two or more circles that share the same center but have different radii. Think of them as a circles in circles with one common point. Properties of concentric circles: they have the same center but different radii. We can see that this circle here, their center is this point. Both this outer circle and inner circle, they have common center. They never intersect except at the common point. You will see that the inner circle does not intersect the outside circle except at the center. The region between two concentric circles is called annulus or ring. This hash region is called ring or annulus. Distance between them. The distance between the inner circle and the outer circle, we can call it gap, and it can be expressed as gap equal to outer radius minus inner radius. Our capital R is the radius of this circle. Our small r is the radius of the inner circle. Areas of annulus. This hash part can be calculated by using this formula. A equal to pi bracket capital R squared minus small r squared, where this capital R represent the radius of the larger circle and this small r represent the radius of the inner circle. Examples of concentric circles in real life. 1. Dartboards, scoring zone. Another example is ripples in water when you throw a stone. Circular tracks in our CDX or DVDX. Another example is archery targets, circular scoring rings. Another example is tree rings, annual growth layers of a trees. Let us solve some examples. Two concentric circles have radii 10 cm and 6 cm. Find the area of the annulus. And the formula for the areas of annulus is A equal to pi bracket capital R squared minus small r squared bracket. Our capital R is the radius of the outer circle and our small r is the radius of the inner circle. A equal to pi bracket 10 squared minus 6 squared. A equal to pi 10 squared is 100. 100 minus 6 squared is 36. A equal to pi bracket 64. 100 minus 36 will give us 64. Let us take our pi to be 3.14159. A equal to 3.14159 multiplied by 64. A equal to 201.06 centimeter square. Let us consider the second example. A circular track is formed between two concentric circles. The outer radius is 50 meter. The inner radius is 45 meter. Find the width and the areas of the track. The formula for the width, which also means the gap between the inner circle and the outer circle, equal to capital R minus small r. And our capital R is the radius of the outer circle. Smaller r is the radius of the inner circle, which equal to 50 minus 45, which is going to give us 5 meter. They also ask us to find the areas of the track. The areas of the track simply means the annulus. A equal to pi bracket capital R square minus small r square. Our r is 50. Our small r is 45. A equal to pi bracket 50 square minus 45 square. A equal to pi bracket 50 square will give us 2500 minus 45 square will give us 2025. A equal to pi bracket 2500 minus 2025 is 475. If we take our pi to be 3.14159, our A equal to 3.14159 multiplied by 475. Our A will be equal to 1492.26 meter square. Practice questions. So, concentric circles are simply circles with the same center but different radii. They form annulus region, appear in many real-life objects, and have a useful formulas for finding distance and areas. In the next video, we will continue with more circle concepts. Don't forget to try the practice questions. Drop your answer in the comments and subscribe so you don't miss any video in the circle geometry playlist. Thank you.